I want to talk about how to handle capacitors and inductors in circuits. So resistors are really straightforward. You just throw Kirchhoff's loops laws and Ohm's law at them, and everything works out. But capacitors and inductors are a bit more complicated. So today I'm going to talk about just the surface level. What happens if they just ask you what happens immediately or what happens after a long time in your circuit? So let's say we have a circuit like this. And then there's a capacitor. Oh no. And then it comes back. Alright, so capacitors immediately when they're okay, let's say it this way. When capacitors are discharged, they act like like a closed circuit, like a short circuit. So when they're discharged, we can redraw the circuit like this. Just completely delete it. But then, as soon as you actually power on the circuit, so I guess I should have drawn a switch in here. Let me add a switch. There's a switch in here. So there's no current actually flowing. But as soon as you close the circuit, it's immediately after you close the circuit, it's going to act like this drawing here with no capacitor at all. But then as time passes, that capacitor is going to get charged up. So it's going to provide more and more, it's going to fight against the current more and more, until eventually, after a long time, it's reached its maximum charge, which is going to be just Q is equal to CV, where V is the voltage across the capacitor at this point in the circuit, which is going to be equivalent to the battery for this circuit. And that's your capacitance, of course, and that's your maximum charge. So after a long time, it's going to reach that maximum charge. It's not going to let any more current flow. So it's just going to be an open circuit, which you can see is kind of implied by the way the capacitor is drawn in the circuit, just disconnecting the two arms. But in other words, after a long time, so this is a long time after the switch has been closed, so now the capacitor is completely charged, the circuit is going to act like this. So for a simple circuit like this, that means no current flow at all. But you could also have a case like this, for example, where now you would just have current flowing all through those two resistors. Alright, so that's capacitors. Now what about inductors? So you might not have gotten to inductors yet, but this is the symbol for them in a circuit. And let's see, if you think about it, capacitors, how do we say, they oppose changes in voltage. So if you try to change the voltage across a capacitor, it's going to slow down that change. Right? So here, that voltage was 0, and then after we close the switch, it tries to jump up to the same as the battery. But it's not going to let that happen immediately. It's going to instead kind of absorb that voltage by charging up until eventually it's completely charged, at which point you have your original voltage difference across that capacitor. Inductors behave as if they oppose current changes. So if we draw a circuit around this inductor, very simple circuit. So, oh, I need to switch again. So initially, when we first close this switch, this battery is going to try and push whatever I is equal to V over R current through the circuit. But this inductor is going to fight that change. So that means initially the current is going to be 0. So immediately after you close that switch, the circuit is equivalent to this. In that instant. But then after a long time, the current is no longer changing. So your circuit was going to be equivalent to this. So this is immediately. This is after a long time. And same thing with this circuit. Oh, I didn't draw two copies here. I'll just draw them over here. So for a capacitor, immediately it's going to, oops, there's supposed to be a resistor here. Immediately it's going to look like this. a closed circuit, and then after a long time, it's going to look like this, an open circuit. So that's just something to remember when you get those questions in the AP that are like, this switch closes immediately, what's going to happen? How much current flows? Or after a long time, how much current flows? You just use these rules. Capacitors immediately act like just a wire, and after a long time, they act like an open circuit, and inductors are the other way around.